All right, let's focus our rewind on area and volume FRQs. We're going to go into the Wayback Machine into 2006's FRQ dealing with this. So they're giving me region R. They're giving me y equals ln of x. You should know what that curve is. Y equals x minus 2. We got that line. So again, I always like to jump the gun. You've seen me do this before. I need to find these intersections. What I would like to do is I would like to find the x and the y coordinates of those points of intersection. So to do so, I need to go to my algebra menu. I need to solve, and I need to set the ln of x equal to the line, comma x, hit enter. Just double check, make sure you plugged it in correctly, which we did. Just look at it, understand what you're looking at. So this intersects, or these two curves intersect to the left at the x coordinate of 0.159. And then they intersect to the right hand side here at an x value of 3.146. Now I'm also going to find the y values, and without even reading the problem, which you probably should read the problem, is what if they want me to accumulate up to down to up, or sorry, down to up instead of left to right. So let's kind of figure out what these y coordinates are. So you can plug them into either of those, and that's a negative 1.839. And then I'm going to plug, again, I don't need to copy anything for this. 3.146 gives me 1.146. All right, let's find the area of R. Now, I don't know how how the AP exams moving forward when you're doing your FRQs, you're probably going to need to write in your blue book the step where you let them know that you're taking the ln of x equal to x minus 2 at, and then I would just show them x is equal to 0.159, 3.146. Sometimes they formalize and call that like A and B. I don't care about that kind of stuff. So if I'm going to get the area of R, I want to go left to right, top minus bottom. So my lower limit of my integral is 0.159. The upper limit's going to be 3.146. And then I want to take the top function, which is ln of x, and then subtract the line from it. But make sure that you put a parenthesis around the bottom function so you can distribute that negative to it, or let the calculator do that. So I have my setup. I'm going to go back to my calculator. I'm going to go to my calculus menu. I'm going to take an integral, and I'm going to go, just be careful, 0.159 to 3.146. I have the ln of x minus, be careful here, parenthesis x minus 2 dx. Let's just do a quick double check, make sure that I didn't plug anything in wrong. And that gives me 1.949. Straightforward. Okay, find the volume of the solid generated when R is rotated around the horizontal line y is equal to -3. All right, so it's going to happen underneath here. And again, I don't care if it's scaled right. We want to revolve this thing down, right? Now, I don't know how you learn this, but I've always formalized this with my students. If we're going to revolve a region down to create a solid, you should have learned that to keep it in terms of x, you're going to do the disk and washer method. So that'll keep me dx. And another key fundamental of volumes of revolution are that you should understand how you're accumulating your disks, right? And in this case, you're going to have a wash too. That's why we're going to call it the dW anyway. So my volume, my disks are going to be areas of circles, and to then accumulate those disks across my boundaries, right, from left to right, will give me my height. And I'm going to show you how to think about this, so hopefully it helps you moving forward. Now there's one fundamental about volumes of revolution with the disk and washer method when there is a gap between the shaded region and the axis of revolution. You're going to have to set up two radii, or two radius. So your first radius should, because we're flipping down, I'll show another one in another one on a different FRQ where we're flipping up. Your largest radius is going to go from the ln curve down to your axis of revolution. And the fundamental is, in the disk and washer method, all radii need to be built to the axis of revolution. That's the fundamental number one thing you need to understand about this technique. Then we need to take the radius squared and subtract it from this radius squared to wash out the opening, right? It's not top minus bottom quantity squared. That is a fundamentally flawed logic there, all right? So I just want to make sure we understand that. I always tell my students, like, draw the situation, mark it up properly, and you'll always get these right. And then if you follow kind of my steps here in the thought process, I'm building it using pi r squared h, right? So I'm going to pull the pi out of the integral. So I've used that. Now my height, if you really think about this thing, and I'm not going to, just visualize this thing going all the way around and what that thing would look like. We're still going left to right on our x intersections. But you should know now that an integral, right, is just an infinite sum, right? It's a continuous sum. All of our series work or our sigma work is going to be more of a countable, discrete sum. So the integral is allowing us to accumulate all these disks from left to right, which will build the height of this solid, right? So this will allow us to accumulate the heights. What we need to do now, and you should probably formalize this for yourself, is you need a radius squared minus a radius squared. I know that's a little sloppy, but that's okay. dx. That's how I would tell my students to build it. Because now we're just going to set up what our radii are. But we need two radius because of this gap between the shaded region and the axis of revolution. So I'm going to take my ln of x, and I'm going to go all the way down, top minus bottom, to my axis of revolution. That's the fundamental. All radii need to be built to the axis of revolution. That's the disk and washer method in a nutshell. Well, it's a little deeper than that, but to kind of help you on kind of remembering this stuff. Now we need to wash out the radius squared into the opening between the bottom part of the shaded region and the axis of revolution, which is the line minus, so the line is x minus 2, minus the axis of revolution, because that's below. So that's my setup. Yell at me when I'm doing stupid things. It's minus 3. Sorry. You're probably yelling at me when I was doing that, but that's okay. I'm going to do this in one take. You're getting the gist of what I'm doing here. Just be careful. I don't know why I said -2 because I think I probably maybe should go up here. In making mistakes is a good lesson sometimes for maybe how we need to organize our thought a little better so we don't do it again, is make sure we know that this is y is equal to -3. And then I would have been a little more careful with that. But I caught it. All right. So let's take pi times the integral. And again, left to right, so 0.159 to 3.146. My first radius, and this is where you can probably simplify it a little as you plug it in. Just be careful. It's the ln of x, and this becomes +3. That would be quantity squared. Minus, now the other radius is x minus 2. Now I don't need to simplify. I'm just going to go +3. I don't need to combine. My calculator will deal with that. And then I'm going to square that radius. Now let's just do a double check and make sure that I didn't do anything wrong. Oops, sorry. Hit enter, and we get 34.199. All right, write but do not evaluate an integral expression that can be used to find the volume when it's rotated about the y-axis. So I'm going to show you and I'm going to teach you two different methods right now, or review with you. So when I tell my students that we're going to create a solid by revolving a region left, in this case around a vertical line, if I'm going to stay in disk in washer, that's going to put everything in terms of y, because I'm flipping this way and I'm going to be accumulating my disk, from bottom to top, right? So I need to go along the y-axis to do that. So that gives me volume equals pi r squared h. That is the fundamental equation to solve for your disk and washer method. So I will do this here. So I'll write volume equals pi. So I'm done with that. Well, we're done with the radius squared up here too. You can see those here. I always like my students to check things off as they go. I think it's a good way to do this. It just allows you to fundamentally maybe have a little more endurance with how you kind of can pull this out without seeing it for a while. All right, I need everything in terms of y, which means I need to isolate my x values. So y equals ln of x, right? I would exponentiate each side, right? So that would be e to the y is equal to e to the ln of x is x. And then the other formula, so I'll put a check on that. The other formula, or the other equation I need in terms of y, I'll take x, and then I'll add 2 to here, and we get that. All right, so I have everything I need. Instead of going top minus bottom for my radii, I need to go right minus left. Now watch me here. So if I'm going to do the disk and washer, my first radius is going to be here, all the way from the right, all the way to my axis of revolution, remember, because we're revolving this thing around the y-axis. And then I need to wash out the opening between the right-hand side of, or the left-hand side of this shaded region all the way down to the y-axis. But I'm going from bottom to top. That's why I figured out the y values of my coordinates of intersection. Now remember, that's going to allow me to accumulate the height of this thing, right? That's how I always kind of visualize or have my students think about this. But I do have a wash situation. So I need to go radius squared minus radius squared but this better be in terms of y. Now I need to go right minus left for my biggest radius, which is actually the line. That's going to be what? Y plus, oh, I'm sorry, I'm over here. Y plus 2 minus 0. And then I need to go right minus left into the wash and subtract that radius squared out, which would be e to the y minus 0. Sorry on a little bit of the sloppiness here, but you're getting the gist. And make sure those radius are being squared and then you're washing out that way. So that takes care of that. Now here's the big one. I don't know how you learned all these things, but I'm going to go up a little bit. Or you can accumulate all of the shells, the infinitely many shells, from left to right and keep it in terms of x. But if you're going to do the shell method, you're going to do 2 pi r, which is the perimeter of a circle. So you're going to create a shell at some point from left to right, including these intersections, right, and in between. And you're going to be revolving and creating a shell with a height, right, that goes from here to here, depending on where you're at along your x interval for your integral. So that would be your height. And again, I don't know if you've learned this or not, so 2 pi r h. So if you're going to do the shell method, which I like to teach both because I like to have let my students kind of understand more than one way to create a solid of revolution. There's another technique, and you can accumulate all of the shells from left to right. But this time, it's all kind of working with itself in terms of how you're going to understand this. So you're going to go left to right, so we're going to keep it in terms of x. But watch why this one's easier. So you're going to have your radius, so there's my 2 pi. There's my radius that I need to set up. And then I need to set up a height. And remember, it's going to be me accumulating all of these cylindrical shells from left to right that will fill in as I'm revolving it, that will fill in to create the solid or the volume of this solid. Now to do your radius, it's just going to be x minus 0. And if you think about it, wherever the x value is on my domain for my integral, it's just going to keep infinitely putting in my x's from 0.159 to 3.146, right? So any radius is going to be, right, from here to here to here. So hopefully, again, maybe you've learned this, maybe you haven't, so just focus on the disk and washer method. And then the height of any one of my cylindrical shells, or my infinitely many cylindrical shells, will just be top minus bottom, which would be the ln of x minus x minus 2. Notice how easy that is without having to do everything in terms of y. Hopefully that helped. The height was taken care of too, so let's cross that off. And keep on keeping on.